So we're going to look at changing the subject. Homework was set on 15th of March. Okay, we're looking at making x the subject. So I need to make sure that x on each equation is on its own. So it could be either x equals and then all the other numbers and terms on the opposite side, or it could be written x equals and all the numbers and terms on the opposite side. It doesn't matter which way round the x is. Okay, so what I'm going to try and do is keep the x on the same side where it currently is for these first 4 questions. Okay, so let's get rid of this and then we'll look at the first question. Now when we've looked at this in class, we've looked at 2 different ways of doing it. Okay, there's the what we classified as the onion method, if you can remember that, where we look at, say, there's x, and we go out in increasing circles around each term that is the closest to x as we go out. Okay, and then similar to an onion, what we try and do is we peel off the layers from the outside, so I'm just left with x. So the first layer I would actually peel off on this one would be the m, and I'm going to try and do this color coded so we can see. And at the minute it is positive m. That's what it currently does. We're adding m to k times x. Okay. We're looking at the next layer in there, which is the blue layer, which is k multiplied by x. So I'm timesing by k. Okay, and then that will leave x on its own. So the middle layer, we've got x on its own. Okay, so if I start with the x, now the other side you can see we've got y. So y is going to be there. We're not looking to move y. Okay, and all we're going to do from the top is we're going to say what we see. But remember, when we take it from this side of the equals to this side of the equals, it has to change sign. Okay, so if we're going to just move it from one side to the other, we're going to have to change sign. So if it is a plus, we're going to convert it to a negative. Okay, if it's a times, we convert it to a divide. So we're looking to change between those 2 types of function. Okay, and it's interchangeable. So if it's a plus, it goes to a divide, to a subtract. If it's a subtract, it goes to a plus. If it's a times, it becomes a divide. If it's a divide, it becomes a times. So if I move a term across from one side of the equals sign to the other, it changes sign. So we know we've got y there, so I'm going to move the m across and it goes from a positive to a negative m. That's the first one I do. That's my outer layer, so I've got to do that bit first. Peel the next layer down, is going to be multiplied by k. So I'll have to move it the other side of the equation, which changes the sign from times to divide, and I divide by k. So my answer for the first one is y minus m divided by k equals x. And I can write that in a fraction form like I've got. Okay. So the next one, again, I'm going to do as a the onion method, as we've looked at. Okay, we've got my x, that's the subject of my formula. The nearest thing to that, again, is my k, and that's being divided by k. And then the one on the outside is my m, and again I'm adding it. So what have each terms that I've got? I've got plus m. This time I've got divide by k, and I'm left with x on its own. So remember, I need to move them to the opposite side. I have y already the opposite side, so that's going to stay there. The m moves across and becomes negative m. It's gone from a positive to a negative when it changes side. Okay, and then I'm looking to do the k to move that over the side, and we're going to go this time from a divide to a times. And if I'm going to multiply it by k, remember, k is going to multiply everything on the opposite side. So if I now move that across and I need to multiply, the easiest way is to put it in a bracket and say k multiplied by y, k multiplied by negative m. So if I wanted to expand this out, this would multiply. So I can write it in the form k bracket y minus m bracket. Okay. If you wrote it as ky minus km, that would also equal x. So both of those would be correct. Remember, my k in this term has to times both terms, so ky minus km. Okay. Looking at question 3, if you don't understand the onion method, or it's not the way that works for you, okay, you can do the balancing method, which we've looked at as well. So if you think now we've got y equals t times x plus mn, and then you imagine that there is a line down the middle of my equal sign. Again, we've got to try and do it in order, so I want to get rid of everything that's furthest away from x, and it follows the same principle. I'm going to take away m and n from the side where the x is, because if I take the whole of that away, if I've got an m and n, m times n, if I take that mn away, I've got nothing. It leaves 0. Okay, so I've got one of those and I take it away, that's going to cancel and leave me nothing. It's just going to leave me tx. Now, because I've done it on one side of the equation, I have to balance it by doing it on the other side. So I say y minus mn, so I can write that down as y minus mn equals tx. So I've simplified it by one step. I've still got something else other than x on the opposite side, so I need to get rid of that. I need to get rid of the t. And again, remember that any two letters that's next to each other are being timesed. Okay, times together. So it's t multiplied by x. To get rid of that and to cancel it, if I divided by t, okay, the two t's would cancel, just leaving me x. So that's going to leave me x on its own. If I do exactly the same on the opposite side, divide by t, you can see I can leave it written in the fraction form. So I'm going to rewrite that out. I've got y minus mn divided by t. And that's my answer to question 3. Going to rub this bottom one out. Question 4. Again, continuing this line down here. So again, I'm going to try and balance the equation. Now, r times x and r times t. R's times in both things that we've got there. Okay. So if I was to divide by r, I'm cancelling the r that's in front of the bracket. So I'm looking to divide by r. Divide by r will cancel this r totally and just leave me with the bracket of x plus t. So that's my way to simplify the first part of the equation. Remember, I've got to balance the other side, so I'm going to have to divide by r. So if I was to write that out in the next step, just going to do it over this side. We've got n divided by r, so n divided by r equals, and I'm just left with a bracket that we can see here, which is x plus t. Now, because the r has gone and I'm not multiplying by it, I can now write that x plus t without the bracket around it. Okay, so I've got rid of the r, I now need to get rid of the t. And we can see from this point here, it's being added to x So to make it disappear, I've got one t and I need to take it away. If it's positive, I always do the inverse or the opposite. I take away the t from both sides. And that will leave me, the t's will cancel because it's going to eliminate itself, and just leave me my x. Now to read what I've got on the left hand side of the equation, I've got n divided by r minus t. Okay, I don't want to put the minus t on the top of the equation, okay, because that's coming after what the r is doing to the n. So it's n divided by r minus t equals x. And that's my answer to question 4. Question 5. On each of these terms, we've got to try and get all the x's on one side of the equation. Okay, we can see we've got 7ax and 3ax this side. So if we can try and combine them, okay, so if we again try and eliminate it from the right hand side of the equation by subtracting. Okay, I'm going to subtract the whole of 3a and x, both sides. On the left hand side you can see we've got 7. I take 3 lots of that away and I end up with 4ax plus tp equals, we've got nothing on the start of that equation and we've just left with r. So if I wanted to make r the subject, I've just done that. But the question asks me to make x a subject. So it's the same as what we've done before, but we've got an extra step in it. So we've moved that similar term across, so we've got it all on one side of the equation. Now we can get rid of the tp, and again if you do the balancing method, take the tp away from both sides. That's going to leave me 4ax equals r minus tp. So I've now simplified that side again to give me 4ax. And if we think about that, what's happening, 4 is multiplying the a, which is multiplying the x. So they're all being times together. Okay, so if I wanted to get rid of the whole of that first section, the 4a is multiplying the x. So I can take it away, I can get rid of it in one section by dividing by 4a. So I'm going to divide by 4a, divide by 4a. Now if I try and write that in a way that it looks a little bit neater, okay, so we're going to do x equals r minus tp divided by 4a, and again I'm just putting it in a fraction form there. Okay, question 6. Similar to how question 4 was when r was multiplying the bracket, on this one we've got h multiplying the bracket. So again I can just divide straight through by h, divide by h. That will cancel that h on the left and just leave me x plus n. On the right hand side of the equation I've got a divided by h. If I now try and get rid of the n, remember I'm doing the inverse, I'm doing the opposite to try and cancel it. Plus n, take away n gives me nothing, so that cancels and just leaves me x. And on the opposite side I've got to do the same, so I take away the n, so I've got a divided by h minus n, and that's my question 6. Question 7 is pretty similar to the one we've just done. So divide through by b, that's going to leave me x minus d equals q divided by b. Get rid of the d by doing the inverse, so I'm going to add a d to it, which is going to make that cancel. Add a d to the other side, and you can see we've already got our equation there. Our solution will be x equals q divided by b plus d. Question 8, slightly more difficult because again we've got an x on both sides. So you can see how as we've been going down, they've been getting harder and harder as we go down. So we need to expand this bracket first. We've done expanding brackets. Whatever's on the outside of the bracket multiplies by what's inside, and then you have to multiply both terms. 3 times x is 3x. 3 times negative 2y, well 3 times 2y would be 6y. Positive and a negative gives me a negative. And I'm going to multiply the other side as well, so we've all got the same terms. 2 times x gives me 2x. 2 times y gives me 2y, and they're both positive, so it has to be a positive. We're going to try and do like we did in question 5 and simplify it by combining like terms. So we could take 2x away from this side, which would give me 0. So I can get rid of that. But I have to balance it the other side. So 3x minus 2x is going to give me 1x. Getting rid of the minus 6y on the left of the equation, I've got to do the opposite to make it equal 0, so it disappears and eliminates. So minus 6 add 6y, minus 6y add 6y eliminates it and it leaves me nothing. So the only thing I've got on this side of the equation now is x. I have to do the same on the opposite side of the equation to make it balance. 2y add to 6y is going to give me 8y. So my answer for question 8 is x equals 8y. Remember, we would have to expand the brackets on this one first. Okay. Collect like terms by trying to transfer it across the equals and doing the inverse, and then solve for x by getting x on its own. Okay, the stretch. Again, only slightly more difficult because we've got some index terms in there. So we've got a square and we've got a square root, but the process is exactly the same. I need to make my subject on these two y. So again, I'm going to do the first one in the onion method and the second one in the balancing method. So I'm only interested in y. What happens to y first? It's being squared, and then I'm subtracting r. So if I try and go backwards, I'm going to take the r over this side and do the inverse. So I'm going to add it plus r. That's now gone. I'm going to take the square over this side and do the inverse, which is a square root. And the square root has to go over all of it, remember? So if I square root something, it's everything that's on that side of the equation. Okay? And that's now gone. And that would leave me y. So y equals p plus r, all square rooted. So again, if you can think about the inverse or the opposite, the inverse of a square is a square root. Okay, the inverse of a cube is a cube root. Okay, and if I go the other way round, the inverse of the square root is the square, and the inverse of the cube root would be to cube it. So let's look at question 10. Question 10. We've got a square root of y minus mn, and that's going to equal s. So all I'm going to try and do is break this down and make it easier at each stage. Now the thing that's over the top of all of this we've got to get rid of first. So we need to get rid of this square root. So if I move the square root to the other side, I do the opposite, and to balance it, I'm going to square it. I'm just going to put the x here, so I've got a letter to, I'm not squaring x, so just think that the whole of that term, let's see what I'll do so we're not getting confused with it. What I'm going to do is I'm going to do y minus mn square rooted. If I square the whole of that, if I square the whole term, okay, then the square cancels the square root and it will just leave y equals mn. It's made it slightly simpler, it's got rid of the square root sign. But I now need to make sure that I square the opposite side of the equation. So I need to square the s equals s squared. That's the only thing I've got over that side of the equation at the minute, so that is what I'm going to square to do the inverse. Coming back to my left hand side of the equation, I now need to get rid of this piece. I can get rid of that in one go because the whole of m and n, whatever m and n is times together, is being subtracted from y. So I'm going to do the opposite, plus m and n, which will cancel. Do that the same on the opposite side. Left hand side is going to leave me y. Right hand side, say what you see, s squared plus mn, and that's my solution. Hopefully that's been helpful. Okay, if you're still struggling, let me know and we can have a look at going through that again. Thanks for watching.